some prints, but you also want props. Prints and props. Yeah!
Hey everybody, and welcome back to another episode of Prints and Props. Today I'm going to be showing you how my Iron Man helmet works and kind of the way that you can motorize and light your own Iron Man helmet. This really isn't going to be a step-by-step, super in-depth tutorial type thing. This is definitely going to be more of a sort of in-depth overview. But hopefully you guys can get something out of it. I will leave everything that you need, all the information on what to buy, where to get it, and all the different pieces that you'll need to 3D print and do whatever with to accomplish this. So hopefully, you know, you get something out of this. So with that, let's get started. Whoops, wrong side. There we go. Come on. I swear sometimes the machines are turning against us. Alright, so as you can see here, I've got my two cameras set up. One so that I can talk to you guys, and two so that you can see a little bit closer up shot of the helmet and what's going on here. And before we get started going into depth of kind of the stuff inside of the helmet, kind of wanted to talk about how you might notice that this helmet is not yet painted. And there's a very specific reason for that. I strongly believe that any kind of mechanics or assembly or magnets or anything that you're going to do to any piece that you're going to have as a finished piece, you always want to do that prior to painting. You want to get all of your assembly, all of your electronics, all of your everything out of the way before you paint. Reason being, if you're going in with a bunch of glue, sandpaper, all this fun stuff, then there's certainly the chance that you run the risk of messing up your nice shiny paint finish that you work so hard to achieve. And then you got to go over and paint again or just live with it. Either way, not ideal. So just do all the stuff before you paint it, and then you can make sure everything fits together, and if you need to break out the sandpaper or the glue or whatever, you're okay. But yeah, so with that, let's go ahead and pop the back plate off of the helmet here. This is how you would insert your head in, because the neck hole is certainly not big enough to allow anyone to insert their head, and that just attaches via magnets. So first, you know, as you guys saw earlier, you've got the up and down motion of the faceplate, and there are two servo motors in this, and there is one in kind of the forehead widow's peak area, and there's one kind of in the bridge of the nose area, and we'll look more into that as we go on. So let's move on to the actual innards of the helmet. Yeah, so my whole thought process behind this whole thing was kind of, I wanted it to be universal. So by that I mean essentially any Iron Man helmet that you want to make, this system should, in theory, work for it. This is the Iron Man Mark 46, which is notoriously difficult to motorize because the widow's peak is really tiny and it's really wide. So some of the other helmets like the Mark II, Mark III, you know, Mark 6, Mark 7, those kinds of helmets are generally a lot easier to motorize, so I kind of wanted to start with one of the more difficult ones to try to get that universal system that should work for everybody. But yeah, let's talk a little bit about some of the things that you'll need to know and some of the things, the actual bits that you'll need to be able to do this. The first thing that you really need to be knowledgeable of is how to solder. You really can't do this without knowing how to solder. There's lots of wire connections to be made, and all of those need to be made with a soldering iron and wires just being butted up and soldered together. So find someone that is good with electronic soldering if you're not, or learn how to do it yourself, which I highly recommend because I've had a lot of fun being able to solder things myself, and I've learned a whole lot as a result of that. So I certainly recommend that you go out and learn how to do that. For this specific project, you don't need a ton of electronics knowledge. Everything you need is basically pre-made for you. You'll be using one of these Arduino boards. This is a little Arduino Nano. They're extremely cheap. And I like these because they have a built-in USB port for programming them and debugging them. But do yourself a favor and don't buy the one with the pin headers on it, because that just raises the profile of your Arduino significantly. Buy the ones without the pin headers on it, and it'll be a lot lower profile. So this Arduino here is the kind of the brains of the operation. It's what listens for a button press, and then sends the signals to the servo motors to go up and down based on the programming. And I will be leaving my program down in the description that you can just flash your Arduino. So that's the other thing you'll need to know, is kind of a basic understanding of Arduino, how to upload programs and stuff like that. You don't need to know how to program necessarily unless you want to go in and change things on this specific program. But you will need to know how to basically use Arduino. The other thing is, of course, you'll need to be good with just kind of general crafty things, you know, X-Acto knives, scissors, glue, all that kind of stuff. But yeah, that's basically it for kind of the things that you'll need to know. Again, I did mill my arms out of aluminum. You could 3D print them. The trouble is finding a 3D print material that's rigid enough and doesn't flex at all. And that's very, very challenging. So I opted to cut mine in aluminum. I am contemplating offering that as a service, both the 3D printed parts and the aluminum parts as well. But we'll see about that. I have yet to decide. If you would be interested in that, feel free to leave a comment down in the description. Or, I'm sorry, leave a comment down in the comments. But yeah, so that kind of gives you an overview of kind of some of the stuff you'll need to know. Some of the stuff you'll need is you'll need batteries, obviously. I like these Energizer Ultimate Lithium batteries. They're 1.5 volt AA's, just like your standard AA. The only difference is, whereas a standard AA has about 1,000 milliamps of capacity, or milliamp hours, sorry, of capacity, these have 3,000 milliamp hours of capacity, up to 5,000 milliamp hours capacity. So they have much more juice, much more current to be able to give these servo motors, and you need a lot of current when you're working with these servo motors because they require a lot of juice. So you need those batteries. You'll need some kind of switch. The type of switch that I like is these little glass magnetic switches. They're just little magnetic reed switches. I'll leave the link for those. They're activated via magnet, so if you go that route, you'll need some rare earth magnets, or just some very strong magnets, neodymium magnets. You can operate this just via a push button, just a regular old push button, but you'll have to research how to do that yourself. You'll need some of this stuff, which this is, I think this is 16th inch wide copper tape. This is what we use to wire the LEDs for the lights together. You'll need LEDs for the lights. These are 5730 LEDs at 6500K color temperature, which is just standard white. You'll need some super glue. I like this Bob Smith Industries thick stuff. You can mix that with baby powder, which is my preferred kind of thick adhesive. Works better than epoxy. It's a lot stronger than epoxy. It takes less time to cure, especially when you use this stuff, which is some super glue accelerant, and that makes it kick off almost immediately. So beyond that, of course, you'll need servo motors to actually do the lifting. And the trouble was with this project was finding servo motors that were small enough to fit in the area that I needed them to, because I like my helmets to fit really snug against the head. I don't like the big bobblehead effect. So they need to be small, but they need to be really strong. And the problem is that the more length that you give an arm on a servo, the torque diminishes exponentially. So that was the other challenge, is the servo arms need to be short enough to not strip the servo motors of all of their torque. So the motors that I found that work really, really great are these PDI HV210 7MG. They are from KS Servo, and I bought those on hobbyking.com, and again, I'll leave the link for those down in the description. So yeah, I think that's about it for all the things that you'll need. So now let's look again at the innards, and we'll go step by step, kind of piece by piece on what everything is. So again, we already looked at the actual servos themselves, connected by the aluminum arms with the 3D printed brackets on the back side of each servo that serves as kind of a widener to help widen the servo body, because you do not want it to be super thin, because then you don't have enough space for both sides of the arm. So you need to widen it a little bit so that the arms can come out and have enough space. So here's my eye LEDs. I'll show you kind of a trick for doing cool Iron Man LEDs to where they look crazy bright from the outside like you already saw, but you can still see them from the inside. And we'll get more into that later. So that all gets wired down. There's a tiny little kind of limit switch or micro switch. It's like a limit switch for 3D printers on the faceplate, and that's what turns the lights on. So when the faceplate's closed, the lights are on. When the faceplate's open, it turns the lights off. So the eye lights are actually not controlled by the Arduino, although you could control them with the Arduino if you wanted to. So let's see here. So let's talk about the power. So I use 5 of those Energizer Ultimate Lithium AA batteries. And that's because the servos require 7.4 volts to operate. And 5 times 5 is 7.5. So wiring these batteries in series, if you wire batteries in series, you multiply the voltage. If you wire them in parallel, you multiply the current. So just Google what the difference is. But basically it means positive gets wired to negative, the next positive gets wired to negative, and it is like a daisy chain instead of positive to positive to positive to positive, negative to negative, negative to negative. So anyway, so each of those is in a just AA battery holder, and that's from DigiKey, and I'll leave the link for that again. Basically I just kind of followed the shape of the chin area here because I wanted all the electronics to be contained under the chin, because that's actually where most of the room was, or is. And so let's see here. So the battery, the raw 7.5 volts from the battery, we needed to decrease to 3.3 volts for the LEDs in the eyes. And to do that, I just used a 3.3 volt voltage regulator. Pretty much any of them will work because you don't necessarily need a low dropout voltage regulator for these eye LEDs, because you're giving it 7.5 volts. So 7.5 volts to 3.3 volts is there's a large gap, so you don't need a low dropout one. And with that 3.3 volt voltage regulator, I had to use some capacitors as well, so I had to buy some capacitors. I just bought a kit that had a whole bunch of different kinds off of Amazon. I'll leave the link. And then, so from the 7.5 volts from the battery, that goes into the VN pins of the Arduino, the VN and ground, which powers the Arduino. And then off of the Arduino, the only 2 connections coming out are to the servo motors for the data pins that tell the servo what angle to go to. And then there's an input pin for the button, so that it can know when a button's been pressed to go to the angles. But yeah, so that's pretty much it for kind of how it's all put together. I have a little switch right here, and that just turns the entire system on and off to conserve battery, so you don't just, you're not using your servos all the time. But yeah, that's pretty much it for the actual kind of electronics. And I just kind of routed the wires through, as best I could, and glued them down and plugged everything in as best as I could. Now let's talk about the eye LEDs, because that's actually pretty interesting. So if you notice, it's kind of, let's see, might be able to see. You see how there's some light passing through there? So the way that works is you take these LEDs, and if you notice, there's a gap in between each LED already. That's how they come on the reel, and these come in a reel of 100 or more when you buy them. So what I like to do is I'll take the strip of LEDs and I'll lay it over kind of the hole where my eye is going, or where I want it to be lit. And I'll just check how many LEDs it's going to take to bridge the gap all the way from side to side. And then I will just take some wire cutters and snip them right there. And then what I'll do is I'll lay my LEDs down on the table, and I'll take some extra strength duct tape, and I will gently peel the protective plastic off. Then I will lay my duct tape over the top of it and really push it down really firmly to stick the LEDs down to the duct tape. Then I flip it over, and then I gently separate the tape from the black backing, and the LEDs themselves actually stick to the tape. So now they're stuck down to the tape with each of those, that gap between each LED. So then I will take my copper tape here and break off a strip, and lay it down on the top and the bottom, and then I will solder in one big giant strip, all the positives together and all the negatives together, and then I'll make a note of which one is positive and which one's negative so that I know how to wire them together later. But then the cool thing is, when you're outside of the helmet, someone outside of the helmet isn't going to see the gaps because it's so bright that it's actually almost kind of hard to stare directly at the lights when they're on. So for you see the gaps in between each one because they're right up against your face. So it's kind of a neat little optical illusion, which I know a lot of people have trouble getting kind of the solid look of the Iron Man lights while still being able to see. So that's kind of the solution that I found that I thought was pretty novel. So yeah, that's basically it for kind of how everything goes together. So now we'll take a look at the code for the Arduino, and we can continue. So here is our Arduino code, and the first thing I want you to take a look at is that the code is not long. It's a pretty small sketch. And the first thing you kind of need to notice is this servoeaser.h, because what that is that's a library for Arduino, and what it does is basically allows the servos to have some form of acceleration. So what that means is most servo sketches only allow you to set an angle on the servo arm, and it gets there as fast as it can, and then it stops. So that can be problematic because if you're trying to do kind of fine motion and things like that, you're kind of slamming down, slamming up, and it can get kind of crazy and mess things up. So what the servoeaser library does is allows it to kind of go zzz, to start slow, speed up, and then slow down when it achieves when it gets near its final position. So, and this is all set for kind of the motion that I found to be the best, and you can kind of play around with this if you know what you're doing. But so that's servoeaser. So you'll need to install the servoeaser library. Google how to install libraries. It's relatively straightforward. You just have to make sure some files are in the right spots. So yeah, let's continue through. So this is the LED pin, and that's not our eye LEDs. That's actually for the built-in LED on the Arduino, and we use that essentially as a debug so that we can see when it's registering button presses. Servo 1 pin, that's just the pin that the forehead servo is on. Servo 2 pin, the faceplate servo. The button pin is on pin 3, which is just the pin that the magnetic reed switch is connected to. And it is important to So I just kind of want to talk a little bit more about the servos here and how they kind of go together. Unfortunately, I couldn't show you the assembly process of this helmet and how I kind of figured all this out because it was a lot of trial and error. So that would not be something good to watch on YouTube. So you get to kind of see the finalized version of all this and not the many versions that failed. So again, if you look closely here, the servo starts right here and ends right here. The servo arm, one of the ones that comes with the servo, is exactly the right size that's designed to slot into the aluminum servo arms. So this is the side with the arm, this is the side that doesn't have the arm, and there's the 3D printed block. And the 3D printed block just has a little slot in it, and that just presses onto the back of the servo. Now, it is important that your servos face the correct way. So see, the wire is coming down on the forehead servo, and the wire is going up on the faceplate servo, or on the, the widow's peak servo. So that is very, very important because you need this little gap here to be as tiny as possible so that your servo arms can be as short as possible to keep your maximum torque. So yeah, the 3D printed part just slots up against that, and it's also important that your bolts here, and these are just regular M3 bolts, that they are on the farthest sides from each other. So instead of being in this little gap here, you know, here and here, they're on the edges of each servo because that lines up the pivot point with the servo arm. And to kind of install the servo arms, it's just you use the screw that came with it, and you just attach the servo arm to the servo, and then you put the aluminum piece over and tighten it. But what I did to give it some extra strength is I actually glued the servo arms that came with the servo using some super glue and some accelerant onto the aluminum first, and then attach them. So something you kind of want to do is once you get everything kind of plugged in, before you glue it all together, just run the sketch and make sure your servos are both at 0, and then just tape or hot glue your faceplate closed really well, and then install everything. And that's just going to make sure that they're at 0 when the faceplate is resting closed, and that you can be confident in that. Okay, so let's just see how this all comes up and works here. So you notice, so one servo controls up and down like this, and then the other servo controls faceplate up and down like this. And let's see if we can get a good image here of how it's attached. So the front servo here by the widow's peak just barely hits the edge of the end of the widow's peak. So that ends up that the arms, or the pivot point on the arms, ends up being right at, let's see, can we see it? Yeah, right out about halfway through the widow's peak. And you can move that forward or backward depending on your helmet. And that just got, when the helmet was all closed up and everything, that got glued in place with super glue paste, the super glue baby powder mixture, and just set in place and then squirted with accelerant to hold it really nice and solid. I did kind of prototype all the glued parts with hot glue prior, because that's removable with some rubbing alcohol, so it's quite a bit more temporary before going all in with the super glue mixture. So, and same thing with this is helmet was all closed up and I just lined everything up, hot glued it first just to check the motion and everything. Once I was confident that was good, used the super glue paste to install that there. So it's kind of hard to see in these angles, but you kind of get the idea of how the motion works here. Okay, well, let's go ahead and actually put it on, and you guys can see how it works. So don't mind my crazy hair that's probably going to stick out. It is really advisable for you to wear like a balaclava or something to hold all of your hair in, especially when your hair is crazy and out of control like mine is. So we'll just go ahead and flip the switch on. The eyes come on and are blindingly bright. There we go. And then hopefully this will go down right. Let's see. There we go. All done. It's a little wily sometimes. Anyway, there we go. It's one more time for you. There you go. Looks pretty good when it cooperates. So yeah, unfortunately I can't go super in-depth as I would like to because, again, this was an immense amount of work and an immense amount of trial and error. But that's about it. So again, I will leave all of the everything you're going to need to do this for yourself in the description. And you know, hopefully you can get in there and get your hands dirty and give it a try. And anyway, so that's going to be it for, well, that's going to be it for me. And we'll see you next time. Thanks.